Welcome to the lecture series of Probability and Random Processes and Applied Statistics. Under this subject, today we are going to discuss gamma distribution. In the last class, we have discussed about binomial distribution, Poisson distribution and geometric distribution. These three comes under the discrete random variable, and gamma distribution comes under the continuous random variable. Look at the definition. A continuous random variable x is said to follow the gamma distribution with parameter lambda if its PDF is given by f of x is equal to e power minus x, x power lambda minus 1 divided by gamma of lambda such that lambda greater than 0, 0 less than x less than infinity and 0 elsewhere, and gamma of lambda is a result integral 0 to infinity e power minus x, x power lambda minus 1 into dx, 0 elsewhere, where lambda is the parameter of the distribution. So, the gamma distribution is nothing but f of x is equal to e power minus x, x power lambda minus 1 by gamma of lambda. Lambda is the parameter of the distribution. And here you can notice that PDF is given. PDF is nothing but probability density function. So, obviously the random variable is a continuous random variable. So, for the continuous random variable only we are having a PDF. For the PDF is given by f of x equal to this form. This is the definition for gamma distribution. Here we have used gamma of lambda result, that is nothing but integral 0 to infinity e power minus x, x power lambda minus 1 into dx, 0 elsewhere. So, for the gamma distribution the parameter is lambda. So, here lambda is the parameter. In the previous class we have discussed normal distribution. The normal distribution, mean, variance and all we have discussed. So, in the leftover question we can continue in the class. Okay, so now under the gamma distribution the very important question is find the M.G.F of gamma distribution, and using it find mean and variance. All the distribution, the first question is the same one, find the M.G.F of the distribution, and using the M.G.F finding mean and variance. This is a common question for all the distribution. So, we know the very well known result mx of t, that is nothing but M.G.F. Okay, M.G.F is denoted by mx of t. So, mx of t equal to what? The result is expectation of e power tx, that is the definition for moment generating function. Mx of t is nothing but what? It's nothing but moment generating function. So, according to the expectation of e power tx for continuous random variable. So, continuous random variable means we are going for integration. So, integral minus into plus infinity e power x, so that is e power tx into f of x dx. Okay. So, here our f of x is nothing but gamma distribution. What is our gamma distribution? Gamma distribution integral 0 to infinity e power tx. Okay. So, the gamma distribution definition is nothing but e power minus x into x power lambda minus 1 divided by gamma of lambda into dx. So, this is the definition for f of x. Now, integration with respect to x. So, we can take the gamma of lambda outside. So, 1 by gamma of lambda into what? Into integral 0 to infinity e power tx e power minus x, x power lambda minus 1 into dx. Okay. So, here we have e power tx and e power minus x. So, this can be written as 1 by gamma of lambda integral 0 to infinity e power tx and minus x. Put together we can write this as tx minus x into x power lambda minus 1 dx. So, in this one 1 by gamma of lambda into integral 0 to infinity e power, if I am taking minus x outside, okay, if I am taking minus x outside, what will happen? 1 minus t, okay, 1 minus t into x power lambda minus 1 dx. Is it clear? So, if I am taking minus x, the term can be written as 1 minus t into x power lambda minus 1 dx. Now, we are going to integrate this. Before integration we can give the substitution. What is the substitution? Substitution is put u is equal to x into 1 minus t. Okay. So, from this here we have x. So, from this we can get our x. X is nothing but what? U by 1 minus t. From this we can take x is equal to u by 1 minus t. So, when you are differentiating this we can get dx equal to du by 1 minus t. whenever we are giving the substitution, we have to check the limit also. Here integration with respect to x, so the limit for x. Now we are giving the substitution to u. So when x is equal to 0 implies, can put x is equal to 0, 0 into anything 0, so u equal to 0. So when x equal to 0 implies u equal to 0. Same manner when x equal to infinity implies u is equal to infinity. So the new limit is also 0 to infinity. Therefore mx of t equal to, now we can write the substitution 1 by gamma of lambda into integral 0 to infinity e power minus u, u by 1 minus t, power what? Power lambda minus 1 dx. Dx is nothing but du by 1 minus t. Here it is t. Okay. So 1 by gamma of lambda integral 0 to infinity e power minus u. This can be written as u power lambda minus 1 divided by 1 minus t power lambda minus 1 plus 1. Here we have 1 minus t, power is 1 into what? Into du. So we can cancel the plus 1 and minus 1 here. Okay. So that is, this can be written as 1 by gamma of lambda integral 0 to infinity e power minus u. Okay. U power lambda minus 1 divided by 1 minus t power lambda into what? Into du. Is it clear? So now integration with respect to u. Okay, integration with respect to u. So we can take the term 1 by gamma of lambda into 1 minus t power lambda outside integral 0 to infinity e power minus u, u power lambda minus 1 into du. Okay. Now already we have seen the gamma of lambda result. What is our gamma of lambda? Gamma of lambda is nothing but integral 0 to infinity e power minus x, x power n minus 1 into dx, which is nothing but what? Gamma of lambda. Now you can compare your integration with this result. E power minus x, we have e power minus u, x power n minus 1, u power lambda minus 1, dx du. So instead of that n, here we have x power n minus 1, u power lambda minus 1. So here we have written this as gamma of n. Okay, this is the result for gamma of n. So this can be written as what? 1 by gamma of lambda 1 minus t power lambda. This is nothing but what? Nothing but gamma of lambda. Here it is n, so gamma n. Here it is lambda, so we have gamma of lambda. We can cancel these two. Okay, so the final answer is 1 by 1 minus t power lambda. What is our left hand side? Left hand side is nothing but mx of t. Therefore, mx of t is equal to 1 by 1 minus t power lambda. This is our moment generating function. Therefore, the MGF, this is the first part of the question, find MGF. So MGF, mx of t is equal to 1 by 1 minus t power lambda. Okay, so using this only we are going to find the mean and variance. To find the mean and variance, we are going to differentiate this mx of t with respect to t. So when you are differentiating this, we can get mx dash of t equal to minus lambda into 1 minus t power minus lambda minus 1. Here we are differentiating with respect to t. So 1 minus 1. Differentiation of t is minus 1. So minus into minus plus. So lambda into 1 minus t power, we can take the minus commonly outside. This can be written as minus of lambda plus 1. Okay, so this is the first derivative. To find the mean, what we are going to do? Put t equal to 0. So put t equal to 0. What will happen? Mx dash of 0 equal to, wherever t comes we can make it as 0. So we can get only 1. 1 power anything is 1. So what is our mx dash of 0? Lambda into 1 power minus of lambda plus 1, that is equal to lambda. Okay, hence our mean is nothing but, therefore mean is equal to lambda. So using MGF, now we arrived the result for mean. After this we are going to find the variance. To find the variance, again this mx of mx dash of t, again we are going to differentiate with respect to t, that is the second derivative, so that we can get mx double dash of t. Okay, in that one also we are going to put t equal to 0. So again differentiating this with respect to t, what will happen? Mx double dash of t is equal to mx double dash of t is equal to, what is here? Here it is, okay, lambda is there, so we can make the lambda, okay, and the power we have minus of lambda plus 1, okay, into 1 minus t power minus lambda minus 2, because here it is minus 1, again 1 minus 1, this will become as minus 2, and differentiation of t, that is 1 minus. Is it clear? So here minus into minus plus and t equal 0, so we can get only 1. Put t equal to 0. Okay, put t equal 0. What will happen? Mx double dash of 0 is equal to lambda into, okay, here it is lambda plus 1. This minus into minus plus, so we can get only 1 minus lambda minus 2. Therefore, okay, mx double dash of 0 is equal to lambda into lambda plus 1. Okay, so when you are multiplying with lambda, we can get lambda square plus lambda. This is our mx double dash of 0. But actually what is our result for variance? Variance equal to e of x square minus e of x the whole square, using moment generating function mx double dash of 0 minus mx dash of 0 square. Okay, so lambda square plus lambda minus mean square. What is our mean? Mean is lambda square. Okay, so lambda square plus lambda minus lambda square, we can cancel these two. Our variance is nothing but what? Variance equal to lambda. Therefore, variance of x equal to lambda. So using moment generating function, finding mean and variance means first we have to find the moment generating function. After find out the moment generating function, that is mx of t, okay, mx of t, we have to differentiate with respect to t, finding first derivative. In the first derivative make t equal 0, so that we can get mean, okay, and then again we have to differentiate with respect to t, so that we can get the second derivative of mx, and then this one we have to put t equal 0, so that we can get mx double dash of 0. This is not our variance. Majority students used to write this as a variance. This is not variance. The variance result we have to substitute this result, that is mx double dash of 0 variance of x using moment generating function mx dash of 0 minus mx dash of 0 the whole square. This is a result. So in this one, substituting this minus lambda the whole square, because mean is lambda. Lambda square minus lambda square will be cancelled off. We can get variance equal to lambda. So for the geometric distribution, the mean and variance are same. Okay. Likewise, for all the distribution, we have derived the M.G.F, and using M.G.F finding mean and variance is the general question for all the distribution. Gamma distribution comes under the continuous random variable. There is one more random variable is there, that is the one more distribution is there. So completing that, we can go to the next topic. So today we have discussed about gamma distribution and its M.G.F, and using the M.G.F we got the answer for mean and variance. Okay, thank you for watching.